Let's solve this physics question here. A medieval prince trapped in a castle wraps a message around a rock and floats it from the top of the castle wall with an initial velocity of 12 meters per second, 42 degrees above the horizontal. The rock lands just on the far side of the castle's moat, at the level 9.5 meters below the initial level. Determine the rock's A, time of flight, B, width of the moat, C, velocity at impact. Okay, here's the picture of the situation. So the prince throws a rock here, and then it lands on the ground here, and has the moat. And the wall is 9.8 meters above the ground. Okay, so let's calculate part A, time of flight of the rock. So part A. Now, what formula should we use? In this question here, it involves the height. So we do have a formula, delta y, that is change in height, is equal to v initial y times delta t plus 1/2 acceleration in the y direction times delta t squared. Now, do we know all the information for the variables here in order for us to calculate delta t? Now let's look at delta y. What's delta y? Change in height. That is y final minus y initial. What is y final? What's y initial? Now, because the prince throws a rock here, I would say this is the initial height, which is 9.5 meters above the ground. And when the rock hits the ground here, that's the final height, which is 0 meters. So delta y is equal to, now final height is 0 minus initial height is 9.5 meters. Then delta y is equal to negative 9.5 meter. Now it should be negative because the height has changed to lower, right? Okay, we have delta y. Can we calculate v initial y? Now, because this is a two-dimensional problem, we have to break this out into the vector. Okay, so he throws the rock at an initial velocity, and that has to be broken down into the x and y component. Here's the x component, and here's the y component. We call this one as v initial y, and this component is v initial x. And of course, the angle here is 42 degrees above the horizontal. How do we calculate v initial y? According to trigonometry, it is v initial times sine 42 degrees. So v initial y is v initial sine 42 degrees. Now, do we know what v initial is? It's given in the question. 12 meters per second. So v initial y is equal to 12 sine 42 degrees. V initial y is equal to, let's put in the calculator. 12 sine 42 degrees is around 8.03 meters per second. Now, let's calculate v initial x as well. What would that be? That will be v initial cosine 42 degrees. V initial cosine 42 degrees. V initial x is equal to, now v initial is 12 cosine 42 degrees. V initial x is equal to, now 12 cosine 42 degrees is around 8.92 meters per second. Okay, now we have v initial y calculated. Next, what is acceleration in the y direction? That will be gravity, right? So acceleration in the y direction, right, is equal to negative 9.8 meters per second square, right? That's the gravity. Okay, we know everything except for t here, so we can calculate delta t, the time of flight of the rock. So let's put it in. Now delta y is negative 9.5 meters. So negative 9.5 is equal to, now we initial y is this, 8.03 times delta t plus 1/2 times acceleration in the y direction, which is negative 9.8 meters per second square, times delta t square. Here. Now, negative 9.8, negative 9.5 is equal to 8.03 delta t. Now, this will become minus. So, minus 9.8 divided by 2 is 4.9 times delta t square. Okay, now we arrange this. Add 9.5 to both sides. We have negative 4.9 delta t square plus 8.03 delta t plus 9.5 is equal to 0. Now we have a quadratic equation. Now let's solve for delta t. We can use the quadratic formula. So delta t is equal to, now this will be negative 8.03 plus or minus square root of 8.03 square minus 4 times negative 4.9 times 9.5, or divide by 2 times negative 4.9. Now delta t is equal to, let's put that into calculator, 8.03 square, right, minus, but this will become plus. So plus 4 times 4.9 times 9.5. Take the square root. So that is negative 8.03 plus or minus 15.83, right? Approximate. Okay. All over now. 2 times negative 4.9 is negative 9.8. Now here, because we're calculating change in time, and time cannot be negative, so we have to take a positive value here. Now, since the denominator is negative number, the numerator needs to be a negative number in order for this to be positive value. If we take the plus side here, this will become a negative value. So we have to use the minus sign. So delta t is equal to negative 8.03 minus 15.83, all divided by negative 9.8. Now delta t is negative 8.03 minus 15.83, right, divided by negative 9.8. It's approximately equal to 2.43 seconds. Okay, so that is the time of the flight of the rock, right? So it takes 2.43 seconds for the rock to land on this ground here. Okay, next, part B, calculate the width of the moat. Now, calculate the width of the moat. Now, because the width of the moat right here is in the horizontal direction, so it's in the x-axis here in the Cartesian plane. So we will use delta x. So here, part B. So we will calculate delta x. Now, for horizontal displacement or horizontal distance, it's usually the velocity times time. But in this case, we're going to use v initial x times delta t, right, times time. Because we're going to use the horizontal component of the velocity. Now we calculate v initial x is here, 8.92 meters per second. And delta y n delta t is what we calculated in part A, 2.43 seconds. So delta x is equal to 8.92 times 2.43 delta x is equal to, now 8.92 times 2.43, around 21.68 meters, or you can round that up to 22 meters. Okay, part C. Velocity at impact. What does that mean? That means you have to calculate the velocity when the rock hits the ground here, which is the final velocity. So in part C, you're looking for V final. What's that equal to? Okay, how do you calculate V final? Now, as I said before, this is a two-dimensional problem. As the rock travels this way in the projectile motion here, it has the x component and the y component, right? As it travels here, right? It's a two-dimensional picture here. So we will draw the x component and the y component. So that will be V final x. That will be V final y. And what's the resultant vector? This is the V final. Okay, and of course, velocity has a magnitude and also a direction. We also have to calculate, let's say this one's angle theta, right? So what's the angle below the horizontal? Okay, now how do we calculate V final? What formula should we use? Now we do know that this formula has V final, right? And as I said before, we have to break out into the x and y component. So let's write this out. V final x is equal to V initial x plus acceleration in the x direction times change in time. And then for the y component, V final y is equal to V initial y plus acceleration in the y direction times change in time. Okay. Now, let's calculate V final x and V final y, right? So we can calculate V final. Okay. V final x is equal to, now, V initial x. Now, we do know what V initial x is. We calculate it here, right? 8.92 meters per second. Plus acceleration in the x direction. Is the acceleration in the x direction? No, there's no gravity in the horizontal direction. So acceleration in the x direction is 0. Times time. Okay, the time is 2.43 seconds. But 0 times 2.43 is 0, right? So V final x is 8.92. Actually, I can just erase the head here, right? In the formula, we don't need the head here. So here as well, right? Okay, so now let's calculate V final y. V final y, and that's equal to V initial y, which is here. We calculate it here. 8.03 meters per second. Plus acceleration in the y direction, which is gravity. That will be negative 9.8 meters per second squared times time, 2.43. We final y is equal to, now what's that equal to? Let's put that in the calculator, 8.03. Now, this will come minus. Minus 9.8 times 2.43, negative 15.78, right, meters per second. Now, as you can see here, we final x is positive, we final y is negative. That would make sense because we final x is in the positive x direction, right? But we final y is in the negative y direction. As it's dropping, right? It's falling to the ground. Now, to calculate v final, how do we calculate v final with this information? Look at this. This is a right triangle, right? We can use the Pythagorean theorem, right? So v final x squared plus v final y squared, and then take the square root of that, it gives you v final. So v final, right? We don't need the head here because we're only getting the magnitude. We're not talking about the direction here, right? So we final x, we're not talking about direction. We're just getting the magnitude. So I don't need the head here. We final y, same thing. I'm only talking about the magnitude. So I don't need the head here. Okay, so we final is equal to square root of we final x square. Okay, let me write that better. Okay, so v final x square plus v final y square. Okay, so v final is equal to square root of v final x is 8.92. 8.92 square plus v final y is negative 15.78. Now square. V final is equal to, okay, let's calculate this. 8.92 square plus negative 15.78 square. And then take the square root. So it's approximately equal to 18.13 meters per second. Okay? So now that's the magnitude. So we don't need head here. Now, we have to calculate the direction as well. So calculate angle theta below the horizontal. And how do we calculate that? Now notice that according to the trigonometry, right? We can use the tangent. Tangent theta here is equal to opposite over adjacent. So v final y over v final x. So we can write that tangent theta is equal to v final y over v final x. Now, theta is equal to tangent inverse v final y over v final x. Theta is equal to tangent inverse, what's v final y? Negative 15.78. Over v final x. 8.92. And theta is equal to, now put that in the calculator, tangent inverse but the thing is, for the theta here, right? It doesn't matter if, it doesn't really matter. We don't have to take into direction here, right? Although this one is in a negative y direction. So in this case, I will erase this negative sign here. Okay, so what will be the answer here? So it's around 60.52 degrees. Okay, that will be below the horizontal, right? 60.52 degrees below the horizontal. Here, below the horizontal. Okay, so now the velocity at impact will be 18.13 meters per second. 60.52 degrees below the horizontal. Okay. So that's the solution to this question here. Hope you enjoyed this video. Don't forget to subscribe to my channel. Thank you.